Hello, Muniba. Good evening.
Good evening, ma'am.
Is my screen visible, Muniba?
Yes, ma'am.
Okay. Okay, so let's start. I think others will not join the class. Only you and Anisa is there. So we have we just discussed the preparation by carbonyl compounds, right? Is there any doubt till here? Mhm. Is it clear? Okay. So today's topic is how we can prepare the corresponding alcohol by your carboxylic acid. Okay, that's again very important and interesting topic. Preparation of alcohols by carboxylic acid. Yeah. So when carboxylic acid is reduced, again the reduction of carboxylic acid will convert the carboxylic acid into a alcohol. Okay, because you know very well, as I told you in the previous class, carboxylic acid will not reduced by a weak reducing agent like your sodium borohydride and catalytic hydrogenation. Okay, H2 in the presence of any catalyst. So these two won't reduce this carboxylic acid in a corresponding alcohol. Okay, only lithium aluminum hydride can reduce this carboxylic acid into a primary alcohol. Okay, so see this general equation reaction. So RCHO, RCOOH, this is a carboxylic acid. When you reduce this carboxylic acid by lithium aluminum hydride, so what will happen? What you are supposed to do? Just reduction means the addition of hydrogen, right? So the one oxygen will be removed from here and two hydrogen will be added and you will get primary alcohol. Primary alcohol. It's very simple. Okay. Now, see, like first question. So it's CH3, CH2, COOH. Hello. I think my Wi-Fi is not stable today. Yeah. So see the first question, CH3, CH2, COOH. Okay, this is your propanoic acid. Okay, CH3, CH2, COOH. On reduction, it will reduce to corresponding alcohol. Okay, so what will be the which alcohol? See, what you're supposed to do, this as it is. Okay, just remove this oxygen from here, add H2. CH2OH. This will be your alcohol on the reduction of carboxylic acid. Is it clear, Anisa and Muniba?
Yes, ma'am.
Yes,
Okay. Now tell me, what will be the product in the second, third, and fourth?
In place of COH, CH2OH.
Good. CH2OH. This one, third one.
Same. In place of
Okay. Okay, now the fourth one. Anisa will tell me. What will be the product in the fourth one, Anisa? There are two groups, and you are using lithium aluminum hydride, and it's a strong reducing agent. So it will reduce both the group. Okay, this is your ketone. So ketone will be reduced to alcohol, right? OH. And this again, the COOH group, it will be reduced to CH2OH. Okay, again alcohol. So you have to reduce both the groups. So this will be OH, okay, in the place of O, and this In the place of COOH, it will be reduced to CH2OH. Okay, this is your product. Now tell me, if I use, suppose this is your structure, this is your O group, and this is your COOH. Now tell me, if I use sodium borohydride, NaBH4, then what will be the product? The formation of product totally depends on the reagent we use. Okay, so in this, see here we were using the lithium aluminium hydride, which is a strong reducing agent. Okay, it will reduce each and every group, whether it's aldehyde, ketone, carboxylic acid, ester, anything. But this sodium borohydride will reduce only carbonyl compounds. Okay, aldehyde and ketone. So what will be the product in this case? So it will reduce this ketonic carbon, right? But it will not reduce this carboxylic acid. Okay, because it is not as strong as lithium aluminium hydride. So what will be your product? So here in this place, this will be reduced to OH, and this you will write as it is. COOH as it is. Because you are using the weak reducing agent, sodium borohydride. Okay, this will not reduce the carboxylic acid. Clear?
Yes, ma'am.
Yes, ma'am.
Yeah. So write on this point, note में sodium borohydride and H2, okay, H2 in the presence of nickel or either palladium or platinum, okay, do not convert this carboxylic acid to your alcohol, corresponding alcohol. So COOH to CH2OH, it won't convert, right? So for example, this is an example question. Suppose this is your compound, okay, and you are using sodium borohydride. Now tell me, the sodium borohydride will reduce which carbon? Like suppose if I give this number, this is ketonic carbon as first carbon, this carbon aldehyde carbon as second carbon, and this carboxylic acid carbon as three carbon. Now tell me, Anisa, which carbon it will reduce in this molecule? This sodium borohydride will reduce which carbon?
Ma'am, the ketonic group.
Yeah, first one. Only first one?
No.
Yes, Muniba?
First and second.
Yes. So it will reduce first as well as second. Okay, because sodium borohydride, as I told you, it will reduce the carbonyl compounds. And what are carbonyl compounds? The ketone and aldehyde. Okay, so these two carbons, first carbon and second carbon, will be reduced, and this will be as it is. Sodium borohydride will not reduce the carboxylic acid. So your product will be this COOH as it is. And here it will reduce to OH group, and this will be reduced to CH2OH. CH2OH. This will be your product. Now see what happens. This lithium aluminum hydride is quite expensive, right? So what happens in commercially when we prepare the alcohol, when we prepare the alcohol, so it is quite this reducing agent is quite expensive. So we first convert it into the corresponding. See, this RCOOH is first converted into ester, and this ester on further catalytic hydrogenation will give you a alcohol. So because of the quite expensiveness, lithium aluminum hydride is quite expensive. So what we do, we follow two-step mechanism, two-step reaction. First, this carboxylic acid, because if you add the sodium borohydride, so it will not reduce this carboxylic acid to lithium, your alcohol, right? Your corresponding alcohol. But here, what we are supposed to do, this carboxylic acid first किसमें convert करते हैं? Ester, and you know ester group can be easily reduced by catalytic hydrogenation, right? Catalytic hydrogenation say you can prepare the corresponding alcohol. Now see reaction. Let's see the reaction. What we are supposed to do here, first what happened? RCOOH हमने लिया, right? This carboxylic acid. And when you treat this carboxylic acid, now how you will convert this into ester? Using esterification reaction. Esterification reaction क्या होता है? What is esterification reaction? Anyone? Anisa and Muniba? What do you mean by esterification reaction? When carboxylic acid and alcohol, okay, combines together, they form ester, right? So, and this reaction is known as esterification reaction. So, we have to prepare ester, okay, by which process? Esterification reaction. So, this is the carboxylic acid. When you treat it with a, suppose when you treat it with your R-OH, alcohol, okay, R-OH. So you will get on the treatment of these two, when you combine these two, you will get a corresponding ester. You will get a ester over here. So R, okay, COO R dash. Okay, so from here, water will be liberated out. This OH from here and this H from here. Okay, this hydrogen from the carboxylic acid and this OH group from the alcohol. They just combine together and they just release as a water. यहाँ से क्या होता है? Water will be liberated out. Okay, and in the place of COO, R dash will be attached over here and it will form ester. It will form ester. First step is done. Okay, carboxylic acid को क्या किया हमने? First, it is converted to ester by which reaction? Esterification reaction. When you treat the carboxylic acid to the alcohol, you will get a ester. Okay. Now, next step, what you are supposed to do in the next step, when you do the catalytic hydrogenation. Okay, catalytic hydrogenation means H2 in the presence of any catalyst. Like when you use nickel, H2 in the presence of nickel, or you can use palladium or platinum, anything, right? So this, when you do the catalytic hydrogenation, so further you will get a alcohol. You will get alcohol. RCH2OH. Okay, this will be formed. Number of carbon should be same. Okay, only you have to prepare the corresponding alcohol. Okay, is this reaction clear to all of you? Anisa and Muniba?
Yes, ma'am.
Yeah. Okay, so write it down. Okay, so from here, this point, this reaction, we know that this H2 and means catalytic hydrogenation of ester will give you a corresponding alcohol. And lithium aluminum hydride can also convert esters to primary alcohol. Lithium aluminum hydride, which is a strong reducing agent, it can also convert this ester to the corresponding primary alcohol. Okay, so what happens here when you use, suppose you just take ester, R, C, O, O, R dash. This is your ester group. COO group is basically, this group is known as ester group. So R group, this is alkyl group, and other alkyl group is attached over here, which is R dash. When you add strong reducing agent, lithium aluminum hydride. Okay, so what happens over here? This bond, this CO bond will be break. This bond will be break. Okay, and this RCO will give you, this CO will reduce to corresponding alcohol. Okay, this CO group. So you can just take it as a ketonic type of group, right? CO group will be reduced to your CH2OH, okay, plus this R dash and O and H. This will make another alcohol. This will make another alcohol. So RCH2OH and this R dash OH. the mixture of two alcohol will be formed. And both are, you can see, both are primary alcohols. Both are primary alcohols. So on reduction of ester, okay, so it will give you a primary alcohol, the mixture of two primary alcohols. Clear?
Yes.
Yeah. Next point is sodium borohydride can't convert ester to alcohol, right? Because it's a weak reducing agent. And ester, there are two oxygen group, right? Two oxygen atoms, COO group is basically a ester, and it will require to remove because there are two oxygen group, right? So we have to remove this two oxygen group, and for that we should use the strong oxidizing agent. So this will not reduced by a weak reducing agent. Okay, weak reducing agent like sodium borohydride. So sodium borohydride will not reduce this ester to corresponding alcohol. Okay, but just remember H2. Okay, catalytic hydrogenation will reduce ester to alcohol. But your sodium borohydride can't. But your sodium borohydride can't. Okay, and your carboxylic acid again. When we talk about the carboxylic acid, so sodium borohydride as well as your H2, okay, catalytic hydrogenation, both won't reduce won't reduce the carboxylic acid to a corresponding alcohol. Okay, but esters की अगर हम बात करें तो esters will be converted to the alcohol by hydrogenation, okay, catalytic hydrogenation. But the sodium borohydride can't convert the esters into a alcohol. Yeah, so just remember this point. Okay, see this question. Okay, this is again important question. So so you can see how many groups are there, how many carbons and groups are there. Suppose this is a first group, second group, third group, and this is your fourth group. Okay, now first thing, when when you are adding a weak reducing agent, sodium borohydride. So now tell me which group will be reduced when you are using the sodium borohydride. This is your first group. First group is the C. This is your COOCH3. This is your ester. Okay, you will combine this group. This is your COOCH3 group. COO group is basically ester group, right? This is your CO group, ketone group. This is your aldehyde, and this is your carboxylic acid. Okay. Yes, Anisa. Tell me. When we use the sodium borohydride, so this sodium borohydride will reduce which groups? Yes. Yes, Maniva, tell me.
Second and third one.
Second and third, yeah, very good. Okay, so it will reduce only second and third group, which is your carbonyl groups. Just reduce these groups. So it will reduce to the COH. this group ester group as it is, and this will be reduced to OH. And the second group here, it will be reduced to CH2OH, and this fourth group as it is. The second group and this third group, CH2OH, and this will be as it is, carboxylic acid. Yeah. Now tell me, when you do the catalytic hydrogenation, then what will be the product? On catalytic hydrogenation, which group will be reduced?
Uh, the first one,
Yeah.
second and third.
So H2 and nickel, it will reduce first, second, and third group. Okay, it will not reduce the carboxylic acid. Yeah. So just reduce this group. So here you will get, so this will be reduced to C double COOCH3 will be reduced to corresponding alcohol, and here OH, and this will give you CH2OH, and this group as it is. It will not be able to reduce this carboxylic acid. Yeah. Now Anisa will tell me, when you use the lithium aluminum hydride, so lithium aluminum hydride will reduce which groups? First, second, third, fourth, which one? Yes, Anisa. If this concept is not clear, then ask me, bache. Anisa,
Yes, ma'am.
tell me, lithium on reduction, when you use the lithium aluminum hydride, so it will reduce which groups? First, first is your ester group, second is your ketone group, right? Third is your aldehyde, and the fourth is your carboxylic acid. So this lithium aluminum hydride, so it's a strong reducing agent, right? So it will reduce which groups?
Ma'am, first,
Only first.
second, and third.
And what about the fourth one?
Not sure, ma'am.
Why not sure? As I told you, this lithium aluminum hydride is strongest reducing agent. It will reduce all the groups. Okay, whether it's a carboxylic acid, ester, aldehyde, okay, any group. So it will reduce all the groups, right? All the four groups will be reduced by lithium aluminum hydride. And what will be the product? So you will write this one, two, three, four, which over here this ester will be reduced to this. Okay, and here this ketone will be reduced to this OH, and aldehyde will reduce to this CH2OH, and this COOH group, it will be reduced to CH2OH. Okay, this will be your product. Okay, now you can see when you are using different reagents, so the product will be different. Okay, so just keep this in your mind. This is very important. Sodium borohydride will reduce only carbonyl compounds, okay, which is CO, ketonic group, and aldehyde. Your H2 and nickel, okay, catalytic hydrogenation will reduce the ester, okay, your ketone, aldehyde, but it won't be able to reduce the carboxylic acid, okay. And lithium aluminum hydride will reduce each and every group. Okay, now you can write it down. Written?
Yes, ma'am.
Okay. Okay, so the next preparatory method is, so tell me if we have discussed the preparation from the haloalkanes or not. Haloalkanes. Carbonyl compounds, yeah, we have already discussed. The third preparation was from the haloalkane. Okay, now write down the heading from aliphatic primary amine. Aliphatic primary amine. Now, who will tell me what is aliphatic? What do you mean by aliphatic compounds? What is aliphatic compound? No one?
They're basically connected by the single, double, or triple bonds, but like not forming a ring or
Conjugated system. Yeah,
yeah.
yeah. But they are not in a conjugated system, just like a benzene. Benzene की तरह नहीं होते, like a double and single bond alternate. Alternate double and single bond नहीं होते, but they are connected by either your single bond, double bond, or triple bond. Okay, so they are aliphatic. They are aliphatic. But aromatic क्या होता है? Aromatic is basically a conjugated system. Means your double alternate double bond, then single, then double bond, then single bond, then double bond. Just like this type of arrangement is your benzene ring. It's aromatic type. But aliphatic is basically the aliphatic could be a cyclic chain. Okay, cyclic भी हो सकता है, but you won't be able to see the conjugated system. See, this is your aliphatic. Nice. Oh, connection is not stable today. Okay, so this type of arrangement is your aliphatic. Okay, aliphatic one. It could be a cyclic ring with a single, double, triple, any bond, but it will not form the conjugated system. Yeah. So from aliphatic primary amine, how we can prepare the alcohol? Okay. So see here, when when amines, primary amines are treated with, see, in this we just take the NaNO2, okay, sodium nitrite plus HCl plus HCl. So these combination, whenever you see this combination NaNO2 plus HCl, so it will give you a nitrous oxide. Okay, HNO2. HNO2 is a nitrous oxide. Okay, and इसे हम कैसे लिखते हैं? HONO भी लिखते हैं. Okay, this is same thing. HNO2 or HONO. Oh no, you can you can learn like this. Oh no. Okay, oh no is a reagent here from the aliphatic primary amine. Yeah. So what happens when you take the aliphatic primary amine? What is amine? So this is this group, NH2 group. Okay, NH2 group. So when NH2 group is attached to the aliphatic chain, okay, so it is known as a aliphatic primary amine. This is the aliphatic primary amine, right? Now, when you use the reagent NaNO2 plus HCl, so it will give you a nitrous oxide, HONO. Okay, and now what happens over here? This HONO come and make bond with this HO, and this is your NO, right? Now what happens? From here, the bond will be break. From here, the bond will be break, and this O, that O, right, OH. So it will make bond with this carbon, okay, and this N2 will be liberate out, and from here this water will be liberated. What you're supposed to do, this is the O no, right, OH, NO, nitrous oxide. So OH will combines with this carbon, Okay, and this carbon and nitrogen bond you have to break. You break this carbon and nitrogen, okay, sigma bond, and you will get this RCH2OH. This is your RCH2OH alcohol, right? Plus, what you're supposed to do, this N2. This N2 bond will be break from here to N2 plus your water, H2O. This is your H plus H, then O. So H2O, H2. This will be your product. What you're supposed to do, right? So OH group will be attached to this carbon and just break this carbon and nitrogen bond, okay? And this nitrogen and nitrogen, so OH will be combined to this carbon and this nitrogen will combine to the nitrogen. Nitrogen and nitrogen, ये दोनों क्या करेंगे? They will make bond and they will liberate as a gas, N2 gas. And from here, the water will be liberated H2O. Okay, these two, hydrogen and oxygen, they will combine together and they will form water. So यहाँ से dehydration will be done. Okay, so this is your product and the byproduct is your N2 gas and your water. Is it clear?
Yes, ma'am.
Anisa, clear बच्चे?
Yes, ma'am.
Okay. So it's example. Just do these questions. Question number 1 and 2. Done? Yes, Anisa, tell me the first answer.
Ma'am, I wrote it like this: CH3, CH2, CH2OH.
Yes, you will get ethanol.
Uh,
Ethanol plus N2 gas plus water.
plus N2 plus.
Yeah. Yes, Moniba, second one.
In the place of NH2OH plus N2 plus H2.
Okay. You will get your cyclopentanol. Cyclopentanol you will get plus your N2 gas plus H2. Okay. So all the preparatory method for alcohols. Method of preparation of alcohol. So we have discussed, I think, 6 methods. 6 methods. Let's see. Yeah. First method from the alkenes. From the alkenes. Okay. And there are 2 methods in alkenes. First one is acid catalyzed hydration. Okay. And the second one is a hydroboration oxidation. So in acid catalyzed reaction, we have learned the symmetrical alkene में हम कैसे करते हैं and the in unsymmetrical alkene. So in unsymmetrical alkene, we are supposed to use the Markovnikov rule, Markovnikov addition rule, right? And in the hydroboration oxidation, it's just opposite. We are supposed to use the anti-Markovnikov addition rule. Next, third method of preparation we have discussed about from the haloalkanes. Okay, so from haloalkanes, it's very easy. Just put aqueous sodium hydroxide or potassium hydroxide and just follow the SN2 mechanism. Okay, nucleophile bimolecular nucleophilic substitution reaction, and you will get corresponding alcohol. Next one, we just discussed about the carbonyl compounds, how we can uh, reduce the carbonyl compounds to a corresponding alcohol, right? So reduction of aldehyde and ketone will give you a corresponding alcohol. Okay, and reducing agent we can use this lithium aluminum hydride. It will reduce all the groups. Sodium borohydride, so it will reduce only carbonyl compound. Okay, we can also use this sodium in the presence of ethanol sodium as a reducing agent. And the fourth one, you can also do the catalytic hydrogenation. Okay, and in catalytic hydrogenation we use the catal H2 and nickel or palladium or platinum as a catalyst. Okay, yeah, this point is very important. So aldehyde will give you a primary alcohol on reduction. Okay, ketone will give you a secondary alcohol on reduction, and the number of carbon should remain same. Okay, we are not supposed to increase or decrease the number of carbon. It should be same. Okay, next, yeah, from Grignard reagent. Okay, reaction with the Grignard reagent is again very important. Okay, so in the Grignard reagent, what you're supposed to remember, so in normal cases, this alkyl group, suppose this is alkyl group and OH group, or suppose this is a R group or halogen group. So in normal cases, what we are supposed to do when the bond will break, so this is oxygen is more electronegative than this carbon of the alkyl group, so it will acquire negative charge, and this will acquire positive charge. Similarly, in the haloalkane, when R will achieve the partial positive charge and the halogen will attain the partial negative charge due to the more electronegative of the halogen group. But in this case, when you use the Grignard reagent RMgx, so this magnesium is a metal, right? And you know very well metal kya hota hai? Electropositive. Due to the electropositive nature, here in the case of the Grignard reagent, here the charges will be different, opposite, right? So this magnesium will acquire partial positive charge, this whole group, MgX, okay? And this carbon of the alkyl group will have the partial negative charge, okay? So this R group will yeah, so Grignard reagent के case में क्या होता है? So R group will attain the partial negative charge, and this R group will attack the carbon, okay, carbon of the carbonyl compound. Yeah. Then we just discuss different uh like formaldehyde. When you add the formaldehyde with a Grignard reagent, so you will get primary alcohol. Then other aldehyde ke saath you will get a secondary alcohol. And when you treat the Grignard reagent with ketone, so you will get a tertiary alcohol. After that, today we just discuss about the from carboxylic acid how you will prepare the alcohol. So it's very simple. Just put the lithium aluminum hydride, and lithium aluminum hydride will reduce that carboxylic acid to a your alcohol, corresponding alcohol. Okay. Okay. And the last method was from the aliphatic triangle. Okay. It's again next. Yeah. Next topic is method of preparation of phenols. Write down the heading. Methods of preparation of phenols. Okay. So how phenols are prepared? First method is from benzene sulfonic acid. Okay, from benzene sulfonic acid, how we can prepare a phenol. So it's very simple. First, we should know how we can prepare the benzene sulfonic acid from the benzene. Okay, so if you take benzene, okay, this is your benzene, right? And if you add concentrated H2SO4, concentrated H2SO4, so what happened over here? So this H2SO4, concentrated H2SO4 will liberate a electrophile. यहाँ से electrophile generate होगा, and that electrophile is basically a SO3H, this electrophile, right? And the electrophilic substitution reaction will occur. Right here, the electrophilic substitution reaction will occur, and you will get a benzene sulfonic acid. Okay, what's the electrophile over here? So SO3H. So here SO3H. Right. So this is a benzene. You will get benzene sulfonic acid. Okay, so first step is what? So by the electrophilic substitution reaction of benzene, you will get a benzene sulfonic acid. Okay, and which reagent you will use? So concentrated sulfuric acid. So concentrated sulfuric acid will give you the electrophile, which is SO3H. Okay, your SO3H plus, this is your electrophile, and this electrophile will attack this benzene. And you know very well, benzene ring is a electron density in the benzene ring is quite high, right? So this will attack any carbon. Okay, so it will attack here, and you will get a benzene sulfonic acid. Now, will be the next step. Let's see. After that, when you treat this benzene sulfonic acid with sodium hydroxide, and you will give some temperature heat. So here you will get a intermediate, which is a sodium phenoxide, ONA. Okay, when you treat this sulfonic acid with a sodium hydroxide, so you will get here sodium phenoxide, sodium phenoxide. Okay, this oxygen has a negative charge and this has a positive charge. Now, next step, when you do the acidification, okay, when you put the aqueous acid, any acid like H2SO4, HCl, okay, aqueous acid. So what happens over here? So it will give you H plus ion, okay, and you are giving the water, okay, hydration करा रहे हो आप acidic condition. Now, what you are supposed to do, this sodium will be removed out, and you will get H over here. You will get phenol. This will be your phenol. Okay, again I'm repeating. First step, when you benzene में जब आप डालोगे concentrated H2SO4, so here the electrophilic substitution reaction will occur, and you will get a benzene sulfonic acid. After that, when you put sodium hydroxide, okay, and little bit heat doge aap, so it will give you an intermediate, which is a sodium phenoxide ion. And this sodium phenoxide ion, when you do the acidification, okay, when you just add, you can use aqueous HCl or aqueous you can use aqueous HCl. So what happens over here? This sodium will make bond with the chlorine, okay, chlorine, and this plus NaCl will be formed. NaCl nikal jayega, and from here this hydrogen will come and make bond with the oxygen, okay, and you will get this phenol. You will get this phenol. So that's how we can prepare the phenol from benzene sulfonic acid. Is it clear? Anisa and Muniba, is it clear, bachcho?
Yes, ma'am.
Yes, ma'am.
Please write it down. Okay, see the next reaction. Okay, it's again very easy. From haloarenes, you can prepare the corresponding phenol. From haloarenes. Can you please tell me which process is this? Because we have already done this reaction in the haloalkane and haloarenes chapter. इस reaction को हम क्या कहते हैं? This process. Yes, Anisa and Monica.
Tandem-based reaction.
No, it's a dose process. The dose process, right? See, so from haloarenes, the conversion of haloarenes, okay, when you treat it with aqueous sodium hydroxide at a high temperature, okay, at a high temperature and a high pressure, because see, nucleophilic substitution reaction in haloarenes is not possible. Okay, it's not possible. Why it's not possible? Due to the double bond, partial double bond between the halogen and the chlorine. Okay, so that bond is very difficult to break. See, because this is a okay, this is a benzene and this is a halogen. This is the any chlorine group, suppose. So due to that, because this chlorine has a lone pair, so it will donate its lone pair to this bond. Okay, and due to that, there will be due to the resonance, due to the movement of the negative charge electrons, there will be a partial double bond character between this carbon of the benzene ring and this halogen. And this double bond, this is very difficult to break this double bond. So that's why nucleophilic substitution, because see, this nucleophile is negatively charged. Okay, that is electron rich. And this benzene ring is again electron rich. So what will happen when this nucleophile, when it tries to approach this carbon, so it will feel it will feel repulsion. तो यहाँ पे क्या होता है? It won't be able to attack that carbon. So that's why the nucleophilic substitution reaction in haloarenes is not possible. But in a very drastic condition, like when you give so much temperature and pressure, so in that condition, some drastic conditions may nucleophilic substitution reaction of haloarene is possible. And this dose processes that reaction. That's the nucleophilic substitution reaction of haloarenes. Okay, when you give, see, the temperature is quite high and the temperature and the pressure is quite high. So when you take the this is your haloarenes, right, chlorobenzene, and when you treat it with aqueous sodium hydroxide, so sodium hydroxide will give you a nucleophile which is OH minus. Okay, OH minus as a nucleophile, and but nucleophilic substitution reaction is not possible. किस condition में possible है? When you give temperature, quite high temperature and quite high pressure. So in these two conditions, the nucleophilic substitution reaction is possible. So we just use these temperature, high temperature and high pressure. So this nucleophile will come and attack replace this chlorine group and just यहाँ पे attach हो जाता है, and it will give you a phenol. And this process is basically known as dose process. Dose process. Just remember, this is very important. Okay, so this process is known as dose process. The nucleophilic substitution reaction of haloarenes to give you a phenol. Okay, this process is a dose process. Now see the mechanism of this reaction. So see, this is a chlorobenzene. Now sodium hydroxide आप treat करा रहे हो, sodium hydroxide, right? Now what will happen at this temperature and pressure? Okay, at quite high temperature and pressure, this will form a sodium phenoxide ion. Okay, sodium phenoxide ion, O minus and Na plus. This is a sodium phenoxide. Now, when you give the dilute HCl means the water is also present, dilute HCl, right? So here, what will happen? This sodium, this Na, it will combine with the Cl and the NaCl will be formed as a byproduct, and the hydrogen, which has a plus charge, because this HCl will dissociate to form H plus and Cl minus, right? So this oxygen has a negative charge, so this hydrogen will come and attach this oxygen, and the sodium has a positive charge, so it will attach the chlorine. Okay, so sodium chloride and your phenol will be formed. Okay, is clear? Mechanism is clear?
Yes, ma'am.
Anisa?
Yes, ma'am.
Write it down. Okay, done. Okay, now see the next one. From diazonium salt. From diazonium salt, how we can prepare the corresponding phenol from a phenol, right? So see, when you take this, now tell me, Maniva, tell me what is the name of this structure? Benzene, which is the NH2 group is attached to the benzene. What is the name of this
Aniline.
structure? Yes. Yeah. So when you take the aniline and when you add NaNO2 plus HCl, so this combination again will give you HONO, right? Now add 0 to 5 degrees Celsius. Okay, so aniline on on addition of nitrous acid. When you put the nitrous acid in the aniline, so it will give you a benzene diazonium chloride. This is a benzene diazonium chloride N2Cl. Okay, this N2Cl. So benzene पे जब attach होता है N2Cl, so it is a benzene diazonium chloride. Okay, so after that, this is a benzene diazonium chloride. So this nitrogen has a plus charge. Okay, because it can only form three bonds. Okay, the valency of the nitrogen is three, so it can only form three bonds. But there are one, two, three, four bonds. So there will be a positive charge on the nitrogen, and on the chlorine there will be a negative charge. Now, what happens in the next step when you add dilute H2SO4, okay, and on certain temperature, so this dilute H2SO4 will give you H plus and OH minus ion, okay. So what happens over here? यहाँ से क्या होता है? This N2 group, okay, these two group, N2 group is a good leaving N2 is a good living group, so it just left the group, it just left the benzene group, benzene ring, and this OH will be attached over here. OH will be attached over here, and here this chlorine के साथ this H plus will be combined to this chlorine, and this HCl will be formed. HCl will be formed from here, and this N2 is a good living group, so just is it left the group, and this OH will come and join over here, this carbon. So it will give you a phenol. So from by diazonium salt, benzene diazonium salt, you can prepare the phenol using this mechanism. You have to remember the reagents. Okay, the reagent has a very important role in our organic chemistry. So every reagent has its role in organic chemistry, right? So first step, uh, see, if in exam you have to write down the diazonium from diazonium salt, how will you convert the phenol? Okay, Diazonium salt to phenol. How you will convert? Okay, so you can start from here. This is step. No need to write it down. This is step. This step से आप start कर सकते हो and easily just put the diazonium salt में आप dilute H2SO4 and this N2 will be removed. Why? Because it's a good living group. So N2 will be removed and the H plus के साथ ये chlorine निकल जाएगा as a HCl and here the OH group will come and attach on this carbon and it will give you a phenol. Got my point?
Yes, ma'am.
Yes.
Okay, right on. Okay, now see the next method of preparation. Hello. Hello.
Yes, ma'am.
Yes.
Ma'am, can you please show me the third method?
Yes, Anita.
Yes, ma'am.
I'm facing the network issue. I don't know why.
Done.
Done? Okay. Now see the next one. From cumene, can prepare from cumene, how we can prepare the alcohol. This is again very important. Okay, so now first let's understand what is cumene. So cumene is this structure on benzene. This is a benzene, and on benzene, if the isopropyl group is attached, this is the isopropyl group. CH, and to the on the CH there are two methyl groups. CH3, CH. So this is an isopropyl group, right? So what is cumene? So cumene is basically a isopropyl benzene. Isopropyl benzene is known as cumene. This is structure, right? So from cumene, how we can prepare the corresponding alcohol? Sorry, not alcohol. We are talking about the phenol, right? So see, on oxidation, when you use the oxidation, so basically from cumene, how we can prepare the phenol? So there are two steps. It's a two-step reaction. First, we have to do the oxidation, followed by acid hydration. Followed by acid hydration. Okay, so see this one. See, this step oxidation I'm doing. After that, this is the first step, oxidation, and second step will be the acid hydration. Okay, H2. Okay, you can use the aqueous or diluted HCl. Okay, also for anything. So in this way, you will get a phenol. You will get a phenol. Plus, the byproduct will be very helpful in this. The byproduct is very important and helpful. This is acetone. Okay, acetone. Now let's understand the mechanism. So see, this is your cumene. This is the isopropyl benzene structure, CH, and on the CH there is a two methyl group attached. Now what happens in the first step? You are supposed to do the oxidation. Okay, what is oxidation? The addition of oxygen. Addition of oxygen कराना है. कहाँ पे कराना है? Between this carbon and hydrogen bond. You have to attach the two oxygen between this carbon and hydrogen bond in the cumene. So this is a cumene benzene, okay, carbon, and that was hydrogen. So between this carbon and hydrogen, you are supposed to add two oxygen, this two oxygen, right? So this you will get this structure, this compound. After that, second step will be the acid hydration. When you are using the aqueous acid, okay, or diluted acid, so it will give you a H plus ion. It will give you H plus ion. Now, what you are supposed to do, this CH3CO, this group will be removed. This group will be removed. Now, you can see CH3CO, CH3. This is your acetone. This is your acetone. Okay. You can see this CH3CO, CH3. ये यहाँ से remove हो जाएगा. And this OH will be rearranged to this carbon. Will come and attached on this carbon, and it will give you a phenol. So from cumene, you can achieve phenol by two steps. First step, you are supposed to add the oxygen, means oxidation कराना आपने, right? And between the carbon and hydrogen bond, this CH bond, you are supposed to add two oxygen. Okay, so you will get this structure. After that, when you do the acid hydration, this CH3CO, CH3, okay, this is a propanone. Okay, this is the ketone CH3CO, CH3. Propanone will be removed out as a byproduct. And this propanone, common name of this propanone is acetone. Okay, CH3CO, CH3 is also known as acetone. So, and this oxygen and hydrogen, this OH will become and rearranged over here, and you will get this phenol. Okay, phenol plus acetone as a byproduct. This reaction is also known as auto-oxidation. Okay, इस reaction को हम auto-oxidation भी कहते हैं, right? And this is very important method of preparation of phenol. Why it is very important? So commercially, it is very important. Why? Because in this, the byproduct is acetone. We just get a useful byproduct. इस acetone का बहुत सारा काम होता है, बहुत helpful होता है this acetone. So phenols are commercially prepared using this cumene. Why? Because as it gives acetone, which is a useful byproduct, very useful byproduct. Got my point? Muniba and Anisa?
Yeah.
Yeah, so this is one is important. Okay, sometimes direct question can come, how you will convert cumin to or cumin भी आ सकता है and directly you can see in the question isopropyl benzene. So isopropyl benzene is nothing, it's a cumin. Okay, so how you will convert the cumin to the phenol? Okay, so just now write it down. Mechanism of each and every reaction is very very important. Okay, and mechanism 100% क्लियर तब तक नहीं होगा जब तक आप खुद से प्रैक्टिस नहीं करोगे. You have to practice by yourself. Okay, just write down the mechanism after the class. Just revise the notes and write down the mechanism by yourself. Okay, just close your notebook. First, let's see what is the mechanism behind that. Just try to understand. And after that, just close the notebook and try to write down by yourself. Then it will be more clear. आप उसमें master हो जाओगे mechanism लिखने में. Only thing is you should know what is the use of this reagent, why we are using this reagent. Okay, and this reagent do will convert which molecule to which. Okay, so you have to remember this, the use of the reagent, why we use this reagent. ये क्या करेगा reagent. Once you understand this, so it will be very easy to write on the mechanism. Reaction understand करने में it will be very easy. Write it down. So this step is basically a acidic hydration. Acidic hydration. Okay, and we can also use the dilute HCl. Written?
No, ma'am.
Okay, write it down and please update me. Reason?
1 में 2.
Okay. Right? Okay.
I'm writing the last one.
Okay. Okay. Right on this one.
Done, ma'am.
Let's see. Let's summarize what we have done till now. So, method of preparation of alcohol is very, very important. See, we have discussed. Basically, I just draw the flow chart for you, so it will be very easy. So, first method of preparation, we just discuss about the alkene. From alkene, second is from aldehyde and ketone. Third one by carboxylic acid. Fourth one is from your ester group. Fifth one is from the haloalkane. And the sixth one is from your amine, primary aliphatic amine. Okay. First one, from alkene, we just learn about the two methods. Acid catalyzed reaction, and the second one is hydroboration oxidation reaction. Right. So just remember what are the reagents we use in these reactions. So in acid catalyzed reaction, so we use H plus in the presence of H2. Okay, H plus aqueous acid. We just use aqueous acid. And which rule we follow? Which rule we will follow in the acid catalyzed reaction? So we will follow the Markovnikov rule. Markovnikov addition rule. Second method from alkene was your when you use the B2 acids, diborane, okay, diborane along with the hydrogen peroxide in the second step. So we use anti-Markovnikov addition rule in this. Okay, B2 acids जब हम use करते हैं in the alkene when it is an unsymmetrical alkene, okay, or any alkene, so we just use B2S6, okay, in the hydroboration oxidation reaction. And which rule we will follow? So anti-Markovnikov addition. Yeah. Now, second one, aldehyde and ketone. So, first method, we learn that reduction of aldehyde, right? Reduction of aldehyde and ketone. So, it will reduce the aldehyde to primary alcohol, right? Second, हमने क्या देखा? It will reduce the ketone to secondary alcohol. Second, that was the first one, first reaction, the reduction of aldehyde or ketone. Second reaction of carbonyl compound will be from Grignard reagent. The reaction with the Grignard reagent. Okay. So in the Grignard reagent, when you treat the Grignard reagent with formaldehyde, now tell me, Muniba, which alcohol will be formed? What will be the degree of alcohol? Primary, secondary, or tertiary?
Primary.
Yes, you will get primary alcohol. Yes, Anisa, tell me, when you use other aldehyde, other than this formaldehyde, like RCHO group, okay, other aldehyde के साथ जब आप treat कराओगे Grignard reagent का, so which which alcohol it will form. Yes, we're not revising the notes. When other aldehyde means other than formaldehyde is treated with a Grignard reagent, so you will get secondary alcohol. Secondary alcohol, right? And what about ketone, Muniba? Ketone
Tertiary.
on addition? Yeah, it's very easy. Tertiary. Okay. Then carboxylic acid. So carboxylic acid में हमने क्या देखा? This carboxylic acid only lithium aluminium hydride can reduce this carboxylic acid to alcohol, right? Only this one. Now ester. So ester में हमने क्या देखा? On lithium aluminium hydride or okay, because sodium borohydride will not reduce this ester as well as this carboxylic acid. But lithium aluminium hydride or your your catalytic hydrogenation like H2 in the presence of palladium, nickel, and platinum catalyst can used as a reduction, okay, as a reducing agent, right? In ester. So ester will reduce to corresponding alcohol on treatment with the lithium aluminium hydride and H2 palladium catalyst. Next, हमने क्या देखा? See, next one was when the alkyl halide, when you treat it with NaOH, basically aqueous हम use करते हैं aqueous sodium hydroxide or aqueous potassium hydroxide. Okay, so here SN2 reaction mechanism will be followed and you will get a corresponding. Last one, yeah, Moniba, can you tell me the reagent which we use in the primary amine reaction of primary amine? Which reagent?
HONO.
Yeah, HON. HON. So these are the summary which we have done in the previous classes, or this is very important, right? Methods of preparation of alcohol, mechanism, reaction, examples, each and everything. Just revise thoroughly, right? Just revise more as you can, and practice more questions like from NCRT, previous year questions, so it will be more clear. कुछ भी questions आ जाए, just use the concept, okay, and just do that.
Ma'am, can you scroll a bit down?
This one.
A little bit up. Or
Okay, I think the time is up. So see you in the next class then. I think this chapter will 1 to 2 more classes. I think 2 to 3 more classes to complete that. And
yes.
okay. So have you guys got the date sheet? When's your chemistry exam?
Ma'am, we didn't get it.
Okay. So do you know which chapters are coming in your exam?
Uh, alcohol phenomena, this chapter.
Chapter haloalkane and halorine solutions. Other
We
than
have
these two?
PT2 coming up, periodic test. So it's
Okay.
probably 1 or 2 chapters.
Okay, 1 or 2 chapters are coming because other students have their half yearly exams, right? And I think 2 to 3 to 4 chapters or 5 chapters are coming in their exam, so that's why I've been asked. Okay, so we will complete this chapter by like 2 to 3 classes is enough to complete this. But please just revise the topic, revise the question, revise the notes first. First, after the class, just revise the notes and try to find the questions. Questions find karo like previous year questions from NCRT. Just try to do the question. And if you don't, you won't be able to solve this. Just ask me your doubt in the next class. Okay, so that's all for today. Okay, I stop it here. Thank you so much for joining. See you in the next class.
Thank you, ma'am. Office.
Okay, Allah Hafiz. Bye-bye.
Ma'am,
Yes, Anisa?
ma'am, yes, ma'am, my chemistry exam would be on 21st.
21st of this month.
Yes, ma'am.
Okay, and which chapters are coming, Anisa?
Ma'am, haloalkanes, haloarenes, alcohols, phenols, and ethers, aldehydes, ketones, and carboxylic acid, amines, biomolecules.
Oh, three chapters or more. Okay, we will complete this chapter. After that, we will start with the aldehyde ketones.